This is working? Oh, okay. Yeah, so today I'm not just going to give you a silver bullet for what you should choose, like what specific tech you should be choosing, but like more like talking about a criteria that you should be using to evaluate what you want, whether you're a student, a professor, or like a researcher, or just a hobbyist. So yeah, a little background about myself. I started fresh out of college as a software engineer at XAM Network, which was just developing websites for games. And we did a lot of like marketing type work. So yeah, basically a web dev. And then I pivoted over to being a DevOps engineer at Insomniac Games. Just kind of got lucky there. But I had the chops. Basically, they trained me from like being a software engineer. We had a lot of DevOps type tools that we were using. So I was able to leverage that and go into DevOps. And then I went into a more DevOps heavy role and site reliability role at Thunderhead. And again, like just sort of ground down on a lot of like dev tools, making good stable environments for people to be testing code and so on and so forth. And then now I am a software engineer at Blizzard. So again, like I'm actually still working on a lot of like dev type tools because I'm in the data pipeline and we also service internally. So a lot of our projects are to help a bunch of different teams across the company. And then when I have a free time, I've done a lot of open source, like I basically stalk people on GitHub. What's your language of choice? These are basically a bit like 4 main categories you'll probably fall under. So the most popular language, anyone have a guess? JavaScript. Yeah, this is from GitHub. You'll see JavaScript. SQL, I don't know why that's so high. And then HTML, it's like all web stuff, and then Python is actually like 4th in terms of like usage. I'm sure the numbers aren't very like accurate. Like JavaScript being way up there is super accurate, but like the breakdowns kind of just, yeah. In general, that's what you're gonna see. Next slide. Okay, so some specific criteria. The way I talk about, like when I'm talking about dev tools and my personal preferences, you wouldn't expect me to like put so much value towards popularity, but like popularity is a huge thing because if there are a lot of people solving the same problems using the same tool set, you're going to have a lot of those things solved and you can just use them and it just kind of just snowballs. So JavaScript, while I have my own issues with JavaScript, it'll be probably the thing you want to be learning. And yeah, like the previous slide is more of to highlight, so dev tools and the language you're going to be using are intrinsically linked. So you just want to keep that in mind as you're thinking about what tools you're using. And so yeah, popularity for a lot of different things is where you want to go first. And then you want to then evaluate what you think is bad about something, because everyone's going to sing its praises, everyone's using it, so obviously it's good for something. The next is development speed. JavaScript gets you out the door really quickly, same as Python. So you want to be able to prototype your idea really quickly, and those are very easy to get things out the door. Performance, that's where JavaScript and Python kind of like are lacking. But again, like if you solve the problem first, you can optimize later. And if you really want performance, like you can start researching on by yourself. And yeah, like get the idea out first and then perform and then scale. So if you're going to be working on large projects with a bunch of different people, you want something that is maintainable or like is easy to test. Again, because JavaScript and Python are very popular, there are lots of problems that have already been solved, and there's a lot of testing frameworks that are developed for them, and you're going to get a lot of really good stuff. You're also going to get a lot of really bad stuff because people are still learning and still trying to like solve the problems that they've been working on. So next slide. So I'm pretty sure you've like being here, you probably already know like what you can be using to edit different source code, things like that. Notepad, you probably like pulled up on Windows machine and just like typed little things. You can use it for code. I wouldn't. And Vim, Nano are basically like your starter text editors if you've ever like had a course where you have to learn Linux. So those are always built in to like into the most popular flavors of Linux. Sublime Text is probably going to be your starter text editor for when you're actually getting serious about coding. It's very nice, it's very clean, and it's not like overloading the senses so much. And then yeah, like use whatever you want as long as like you think you can get something done in it. And then again, like some of these editors, I believe Vim and Sublime Text especially can be extended to be like full functioning traditional like IDEs. And yeah, so what is an IDE? It stands for Integrated Development Environment. If you've taken like a Java course, an introductory Java course, or a C++ course, you've probably been like assigned like some opening coursework to figure out how do you even use this thing. Visual Studio is most popular for like C++, C#. It's a Microsoft product, and that's probably going to be your standard starter for like a C++ class. And it's usable once you figure it out, and like you don't have to interact with all the features to be able to like use it effectively for school. But yeah, it's large. Sometimes if you're trying to be a power user, it's a bit clunky, but it's pretty good. IntelliJ, a lot more streamlines, a lot less bells and whistles like on the front, so that it's not so it's not so like overloading. Eclipse, more so an overload from what I remember, and VS Code is basically just Sublime Text with a step above, more batteries included. So why am I mentioning all these? Again, like so my personal experience with text editors and IDEs is that I like environments that don't have too much to begin with, and I want to add on top of it as I'm building my workflow. So that's why I default to VS Code. But at work, I actually use IntelliJ because there's a lot more features that I can use to collaborate with my team that's like just built in, so I don't have to like. And then it's also building a standard language across your teams. If you are working on something and it breaks, you want your team to be able to quickly help you fix it. So yeah, a lot of factors that play into what tools you want to be using. In general, like VS Code is usually all you really need, but I'm not going to be shilling for VS Code. Like every one of these things have been like worked on for years and years and years to be able to like cater to a developer's needs. Okay, some specialized IDEs that I'll be mentioning. So if you're going to the gaming, you're going to want like something like Unreal, Godot, Unity. Those will have built-in like 3D modelers, or like Blender is actually the modeler, and the Unreal and Unity have built-in like 3D spaces that you can use to simulate the objects and like actually see how the game is being played. And then mobile development, again, you want something that you can visualize what you're building. So like Android Studio and Xcode are like basically your main starters. If you're ever building multi-platform though, again, Unity for gaming is really good. I can get into the minutia about like why things are good for different things, but there's a Q&A session later. For mobile, there's a lot of different options. I would go with the one that is focused on one platform first, to just sort of like get you in the door. Like all the like multi-platform stuff, you will lose focus trying to debug why doesn't it work on this platform? Why doesn't it work on? Why does it work on one over the other? And yeah, like you want to target your focus on one specific thing, and then branch out to multi-platform. No, slide. So version control. Why Git? Well, it's distributed control. It's the most popular one. It's an industry standard for like almost everyone except for gaming, which I'll get into later. And because it's so popular, it has that extensive knowledge base. Like if you go and look up GitHub Git documentation, you'll probably end up on GitHub, and there's like a bunch of different stuff, like step-by-step things to basically troubleshoot your problem. And then there's large trusted providers like GitHub and GitLab. Of course, you can roll your own, but like you don't want to be dealing with a bunch of security hassles. And yeah, like because this is so popular, everyone's going to be on like GitHub, and that's how you can like not market. Yeah, it's sort of like how you can market your project if you want more people in open source to contribute to it. So that's why Git is so like used in industry and for hobbies and for anything you would really need. So why not Git? It doesn't handle binaries well out of the box, so that's another reason why it's not well-versed for gaming. And it doesn't scale well for large code bases. When you're working with a Git project, usually you're going to have a lot of different repos that sort of tie in together. If you're doing anything that's like larger than 100 gigabytes, probably not going to end up doing that unless you're like in industry. But yeah, that's pretty much all I have on that. There are some other, so the thing that we use in gaming mostly is perfors, which is very good at checking in large binaries. I believe Mercurial is better at that as well, and it's also distributed. But examples we can leave till later. So code quality. When you're talking about scaling your project, you want to be able to like distribute it to a lot of different people across the company or just in open source. And to do that effectively, you want to know that your code is actually like readable. So whatever language you choose, just research, figure out like what you need to be able to validate a lot of the code that you're writing, because like without good testing, you're going to get bitten in the ass a lot of the time. So I would suggest, like, if, for example, you're working with Node.js, there's like built-in tools like you can just say anything you put in a test directory, you would be able to do npm test, and then it runs all of the code for your tests. And then there's a lot of different packages for it, like Mocha. Different frameworks. Just research, know as much about the tooling for your language as possible before you start. Linting. What does it mean? So most of the time, linting would mean like formatting your code. Some linters also provide like good code snippets or like more idiomatic ways to write your code. Idiomatic means like, is there a specific way or sort of a language feature that you could use that is specific to Python or JavaScript that makes it more readable? So as an example, Scala is a functional language. And so it's going to be optimized towards using the standard library, which calls a bunch of functions. And that's generally the way that you would want to write Scala code. It becomes more readable. So that's a good example about like linting in a way that makes your code more idiomatic. Yeah, so auditing project dependencies. Originally, this talk was actually supposed to be more like a supply chain talk, but I didn't want to get into security, mainly because like I am not a security expert. I have just been doing a lot of research into making our packages more modernized and taking care of CVE holes. But yeah, like npm has a really nice auditing subcommand, and it'll run through all the registries and see, hey, has this package been marked as having a security vulnerability? A lot of tools, a lot of modern tools will have this functionality built in. Like I know Go has this, Rust has this, but yeah, like read into that, figure out what you can do with your tools. Again, benchmarking, I'm not gonna have a long spiel about benchmarking, but it's important. It's, again, a thing you need to research specifically for your language. Yeah, it's tied intrinsically to testing. Setting up your test environments. So you're gonna hear like a lot of buzzwords like containerization or like microservices. Just like ignore those for now. You want to be learning what is Docker. So it's a way to package up all your dependencies into one isolated environment and run a process with that environment. So that is very effective for running tests because you don't want to just run tests on your computer where you have everything already set up. What if you need to spin up a project somewhere else remotely? You don't just know that your environment is set up. So you want to start with a clean slate and then figure out exactly what you need for that container to be able to run your tests properly, or run it like in a live scenario. So I can take Q&A after that about specifics, but some CI/CD options. Continuous CI/CD stands for continuous integration and deployment. And some things you can research about are GitHub Actions, Jenkins, and TeamCity. They're generally like automated environments where if you have a container, a virtual machine, or some scripts you need to run, they'll let you run all those and then report back what the results are. And they're usually constantly running so that everyone on your team can be developing and moving forward. A little side note about doctors for tools. You're going to find this in Brew and a really cool tool called Flutter. And those are just going to be like subcommands that you run to be able to evaluate, hey, are my tools set up properly? I haven't seen those in a lot of tools so far, but they're really handy. I wish more tools would have those when you're setting up development environments. Okay, I think that's it. Oh, yeah. How many of you know how to code? You just raise your hand. Yeah. No, seriously. Because like nowadays, AI has taken over. I've interviewed some people who really don't know how to code at all. And I know like personally some people who've graduated and are still using AI for most of their job. Like it's junior engineer problems. So AI tools are great. Like go ahead and use them. But you need to be mindful about whether or not they're assisting you or if they're replacing you. You don't want them replacing you. There's still a lot of problems that real humans need to be solving because I have run into brick walls with AI before, and they don't solve all your problems. And if you don't get to the point where you can start solving those problems, then where are we going to be? You're just going to keep on using text completion and trying to like get the machine to get like basically hit a brick wall. So AI tools are very good for diagramming, like taking notes, learning things, but they're not good at debugging and optimizing code. Sometimes they're good, but that's only because they've been fed a lot of specific problems, so they know where the pain points are of those specific problems. But sometimes you do something weird like me, and then like you're stuck for 5 hours trying to debug it. And they also don't have large they don't have large contexts for large projects. So how would they know where a pain point is when they can't hold all that in memory? So there are some problems, but like, of course, use AI tools. Text completion is super useful, and it makes you less lazy sometimes. So, all right, Q&A. I am obligated to say Blizzard is hiring. Send me your resume. I'll evaluate it and try to recommend you for a role that I think would be suited for you. My team is hiring specifically for data engineers, but at the senior level. And yeah, any questions? Yes, Jacqueline.
Yeah, so like with the AI piece, do you have any like rules of thumb that you use for like if you get stuck on something, when do you go online to look for something? When do you turn to AI? Like how do you decide whether it's an AI question or not?
Yeah, so I usually just start at search just because like that's where I'm most comfortable with. That's how I develop. I'm old, I guess. But any problem you could so let me think about this. If I think I need to write something really quickly, then I'll go to AI. If I don't know something at all, then I'll search like broadly some topics on a search browser, like on search. If I have a pointed question, I'll ask AI about it. If I have something to debug, I'll go to search first, and then I'll go to AI. Because like I'm trying to go on a broad scope and then narrow it down. Yeah.
Makes sense. Thank you.
Mm-hmm. Any other questions? Yes.
Hello. You mentioned Perforce earlier.
Yes.
How does GitHub LFS?
Yeah. So
a viable solution for something like GameDev?
I think it is viable, but because Perforce is so popular and because like there's a lot of tooling already around it, and its batteries included, it's dominating like the enterprise gaming space. I think LFS is possible to use. It's just don't use it. I mean, it's all open source, so hopefully like there's more work being done with GitHub and LFS, like Git and LFS. In general, so it gets to the point where like it can be used at an enterprise level, but like the driving force will be like more like open source or small studios because it's the free option. Yeah.
Thank you.
I have a question. What's your favorite Blizzard game?
Oh no. Oh, that's a heated answer. I played a lot of Hearthstone. I don't anymore because I have a life and a job. Yeah. Occasionally, like a lot of my coworkers do want to like do game time, so like I'll probably join them. But like I don't want it to be a full-time thing. Like I do mainly board games now, so.
Yeah. Well, thank you, anhquan. And
Thanks.
everyone can give anhquan a round of applause.